this method is it's a kind of important. So we're gonna look at these questions here. They say let f, they have a dy dx, which is the slope. Well, actually, I should talk about slope field first. Let me talk about slope field first. So differential equation. Okay, so first of all, let's talk about how do we draw the slope field, which is most of you guys already know how to draw slope field, but it's only for the people who is not sorry, let me show you here. Quick time. Okay, so that's it. So in order to draw slope field, that you basically just gonna figure out what dy dx is equal to. They already give you a dy dx. So for example, the first one, if you what happened? I'm gonna put on notability. That's easier. Okay, so for here, so for the first one, you're just gonna write out the x and the y and the dy dx for the first one. And so what you're gonna do is you're gonna figure out a certain slope. You already know that when dy dx is equal to 1, the slope is gonna look like this, like exactly 45 degrees. If dy dx is equal to 0, then it's gonna be a horizontal line. Does that make sense? But this is the one that you always have to find out, because on AP exam, if you find out when the derivative is equal to 0, automatically you're gonna get 1 point. Rest of the slope only worth 1 point, so that's the first slope you should find. The dy dx is equal to 0. Dy dx is equal to -1. The slope is gonna look like this. Now, obviously, you're gonna have just like a rise over run. So 1/1, that means like 45 degrees. 0, -1. Now, of course, if it's a dy dx equal to 2, then it's going to be a little bit steeper before. Now, AP exam, they're not very picky how steep you are. And dy dx is equal to negative, let's say it says 1/2. Then it's going to be a little bit flatter because that's go up 1, right, 2. Is that okay? And dy dx is equal to -2, then it's going to be like a little bit more steeper like here. And dy dx equal to -1/2 is going to be this way. So make sure that you have pretty much this. You know, a little bit more steeper, a little bit less steeper, they don't really care. They care about the 0 slope. So how would I do this question and just looking for the 0 slope? How do I get the first point? Well, when x is equal to -1, the dy dx is going to be always equal to 0. Because this is going to be any, because the dy dx is not based on a y value, so it could, because there's only an x plus 1 here. So here it's -1, dy dx is going to be 0. So x equal to -1, that's automatically this. I'm going to use the red line. And if you just draw it out this on AP exam, on that, this is going to give you a word at 1 point. So it's very easy. Now, what happened when it's 0? 0 is going to be 1, right? Does that make sense? And that's going to be 1. So dy dx is going to be right here. Does that make sense? And this is a -1. Let's say -1 is going to give you a -2. That's going to give you -2 is going to give you any. Sorry, this is any. This is any. This one's going to give you -1. So the slope is going to be right here. And after that, it's going to be a little bit more steeper because very steep and almost like, and I can draw out this. You just have to figure out like this. Now, this is what happened. It's based on just only an x value. Some questions based on both x and y. So in this case, that in here, I'm based on x and y. So x and y, and this dy dx. Again, you gotta figure out when dy dx is equal to 0. When does dy dx is equal to 0? Well, yes, but what else? Like, what's a general trend that create that dy dx is equal to 0? They are opposite to the other, so x and y are opposite. So can you give me an example of that? This is once you find out one example, you can figure out the other one. So let's say x is 1, y is -1, right? So here it's gonna give you a 0 slope, right? It turns out there's a 2 and there's a -2. That's gonna give you a slope. You should see the pattern here. The pattern is here. It's gonna be all 0 slope right here. Once you figure out a pattern, you know that you just have to be opposite to each other. It could be like -1, this is a +1. So all this is going to be 0. Anything to the right of that, just say, for example, you have 3 as an x and the y is -2, then that's going to give you something like, I think this, 1 slope. Does that make sense? Does that make sense for you guys? And all here is going to make a -1 slope. And so you can see, you can draw out rest of them, and that's how you get points on AP exam. And there we go, that's slope field. So you're gonna have a slope field worksheet here on all of them, and also some differential equation. But sometimes I will give you a slope field and ask you which graphs match that slope field. So a lot of time, like when you have this case, you figure out what a 0 slope is, you can eliminate a lot of things. And also you can plug in some type of value, you can figure out a positive and negative slope. You can eliminate something. So try those specific points, like specific x and y. You can eliminate some points, you can figure out which one is a right slope field. So there you go, this is a slope field equation. You are gonna get some of those on the AP exam. Thursday's test is fairly easy. It's gonna be differential equation like what you did last year. But it turns out on AP exam, they also have the same questions. Except Euler's method. So Euler's method, if anything you have not learned, that's the only thing I need you to know. It's 100% on AP exam. Not only 100% on AP exam, it's probably gonna worth 3 points. It's gonna be 1 from multiple choice, 2 from free response. And it's not something you don't know how to do, which is nice. But let's talk about Euler's equation, right? Do you guys remember the movie Hidden Figure?
Yes, I love that movie.
Did they talk? Do you remember that when she talked about Euler's approximation? Yes, that's the movie. So let's go look it up. Guys, Hidden Figure, Euler's method is saying. There we go. There's.
Myself is the hardest thing I can do.
The problem is when the capsule moves from an elliptical orbit to a parabolic. There's no mathematical formula for that. Because we can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
Maybe we've been thinking about this all wrong.
How's that?
Maybe it's not new math at all.
It could be old math. Something that looks at the problem numerically and not theoretically. Math is always dependable.
For you, it is.
Euler's method,
Euler's method.
yes,
But that's ancient.
but it works. It works numerically.
That's it.
Let's type it up.
Yeah, it's talking about like when you were in now I don't know the actual math of this. I need to probably rely on like a student of mine can actually explain that. She is in MIT right now, so she just graduated, but she can probably explain the actual math about that. But you know, when you go into space, you want to go into the orbit, so you know a lot of things can change. First of all, it went from elliptical to for like a parabolic to conic, which is elliptical curve. So you want your satellite to be orbit into around the Earth. So there was some type of like missing things there, which is you cannot really evaluate it by a certain formula. We can only go with an approximation, right? We can only go with approximation at that moment. And approximation, if it's something that's really close by, it's gonna be very, very useful. So for example, let's just say if today I have an equation, right? An equation is going to give you some type of equation tangent line. So Euler's method is no different than anything. It's a tangent line approximation actually, but with the multiple iterations. So for example, like says we want to I think before we try to calculate, let's say
We can't see.
sorry. Before that we try to calculate, let's say it's square root of 24.9, right? Do you guys remember this question? We're trying to evaluate square root of 24.9. And the way to do it is because we can build this equation. We can say that's a square root equation right here. Are you following me so far? And let's just say this is 25. We know square root 25 is going to be 5 in this point right here. But at the same time that there was an equation tangent line here, because back then you have no calculator, but we don't know where the thing is. So we can figure out an equation of this line based on, we can take a derivative at that point, right? Does that make sense? Now, if we have a small dx change, let's say it's 24.9, then at this particular value here, so let's just to actually graph it. That's to say it's square root of square root 25, square root x right here. And that's gonna be a point of 5, a 25 comma 5. And that's gonna be a label. That's going to be a point here. So this is it, right? So we can use tangent line approximation to approximate what happened is 24.9, but figure out what the slope is. So let's go back to look at the equation. We says, well, we assume that equation square root x. And we can say dy equal to 1/2 x to the negative 1/2 dx. So that's how much it changed. So, or we can figure out slope. I just say, let's just assume that we can do it either way, right? 2I dx equal to 1/2 x of negative 1/2. And we can plug in 25. So dy dx at x equal to 25 is going to be 1/2 times what? Square root of 25 is going to be 10. So that's going to be 5, right? So it'll be 1/10. Is that okay? Aiden? Is that okay? So this is slope, right? So can I use the equation tangent line? So y minus 5 equal to 110 times x minus 5. X minus 25, thank you. So this is a tangent line. I find out this line of this blue line, right? So don't worry about this part. I find out that this line, and then can I just plug in, says 24.9? Because now I can use that approximation. That's 24.9 minus 5, which is that's equal to 1/10. Minus 25, thank you. So that is going to be, what's 25? Negative 1/what? 10, right?
Yep.
Is that okay? So y minus 5, so y is equal to negative 110. Negative 100 plus 5. So it's going to be 4.95? No, 4.99, right? 4.99. So this is the approximation because we use this line. We use this line to approximate. Now, what Euler's method says, well, can I do it with 2 iterations? Can I go to, let's just say, can I go, instead of 24.9, I'm going to go with 24.95 and do an equation tangent line on 24.95 and do again to seize 24.9 to see that iteration. So the more iteration, the more accuracy is going to be. Now, that just says I'm totally fabricating this because I don't know anything about space traveling. I just assume that you have a payload, like you go and shoot the rocket to the orbit. Now, the booster is gonna fall off, right? Then your rocket is gonna have a similar velocity, but your weight is different. So it becomes a new equation. So we can only at that point we figure out what was the tangent line is going to be, what the slope is going to be, and we can approximate, use as many iterations as possible. Then we can actually figure out what happened. And the same thing, they go from parabolic to conic. It's same situation. It's that approximation of small iterations that you can do. Yes.
It's not like a limit. Isn't it like you're just approaching a point? Like a limit?
Yeah, you well, it's not a limit because you're trying to find the slope at that point.
Oh.
And then you base on that equation tangent line, you go to the next point, and you base on that the new slope, and you base on that to draw the next predicted point. So it's kind of predict what's going to happen next, but using the equation tangent line. So instead of doing one equation tangent line here, I'm going to go with 24.95 first. And at 24.95, I'm going to do it again to 24.9. So it according to theory, that should be the more iteration I do, the more accurate it's going to be. Does that make sense?
Yeah.
Okay. So basically, it's just equation line, tangent line twice. It's nothing abnormal. So we're going to pick the questions here from AP exam. So we're going to pick this one. So now let's look at the question. It says let f of x be a particular solution of the differential equation initial condition f0 -2. So that's the initial condition. Now we have a dy dx. We have a slope equation, right? And then they say start with x equal to 0 at a step size of 1/2 to approximate f of 1. To approximate f of 1. Now remember, put in mind that you're gonna get, yes. Sure, I'll try. Is that better? That better? Okay, so let f of x be a particular solution of differential equation with the initial condition of 0 is equal to -2. Use Euler's method start at 0 with a step size of 1/2 to approximate f of 1. So what happened is, if you use 0 and -2, obviously you're going to get some type of slope by plugging original functions, plugging differential equation. Now you're going to get a slope and you're going to equation tangent line. Now instead of go straight to 1, I'm going to go to step size of 1/2. Now at 1/2, you're going to generate a new output. Does that make sense? And you base on the new output to put on the new slope. How many of you guys are confused? Okay, so we're going to try it. And that way you can see it. Okay. So we're going to write down this information. So let me take a picture of this and let me import it to Notability. You guys want to try it first? If you understand it, you want to try it first? It basically two equation tangent line. It based on f of 0 and -2. And then you're going to go, instead of plugging 1 directly, you're going to plug in 1/2. And then you go from 1/2, you're going to generate a new output. Going from that new output, going to figure out what's the other half. Okay? Ethan look at me, that's like, what the hell are you talking about? Okay, so that's fine, that's fine. I'll show you how to do this one. So obviously, I probably do a chart. It's easier to recognize. You can see the. Okay, sorry. So basically, dy dx. So basically, I'm gonna do a chart so that way it's a little bit easier to see. Right? What happened if you have x equal to 0? This is the initial condition. Is that okay? Can you figure out what a dy dx is? Well, dy dx is 3 times 0 plus 2 times -2 plus 1 is equal to -3. Good. So can I use the equation tangent line? Y plus 2 is equal to -3 times x minus 0. Is that okay? So y equal to -3 times x minus 2. Now what we're going to do is, instead of approximate what happened at 1, we're going to approximate what happened at 1/2. What happened when at 1/2?
So it would be -2 minus 2.
-3 times 1/2 minus 2, that's equal to -3 over 2 minus 2. Sorry, let me text something.
Oh no, wait, I forgot it was negative 30. Okay, so then I do. Now I fold this one. Oh, okay, so you do it over and over.
So this is a -7/2, right?
Y plus 7/2. What? Oh.
Did I do it wrong? Did I do it wrong? Okay, so now I'm gonna plug in to the dy dx. So be 3 times what? The x value is 1/2 plus 2 times -7/2 plus 1 is equal to what? Well, so this one is going to be 3/2. That's 2 cancel out. It's going to be -7 plus 1. So it'll be 3/2 minus 6, I think.
Yeah.
So that's 12. So it's going to be -9/2. So now we're going to use this information to use the equation tangent line to figure out what happened. So y plus 7/2. Is that okay? It's equal to what? -9/2 times x minus 1/2, right? So we base on this new equation now, and to approximate what happened at 1. So y equal to y plus 7/2 equal to -2. Now x is going to be what? X is going to be 1, right? Is that okay? Wait, the class is already over?
Yeah.
Okay, so here it's going to be, hold on a second, -1/2. Y plus 7/2. So y equal to -9/4 and minus 7/4. Wait, is 14/4. So that's going to be -23/4. And that's the answer for this one. So basically just 2 iterations of an equation tangent line. Is this okay for everybody? Richard, you understand?